Okay, so if we can welcome Mohammad Mayouf, multiple perspective considerations of building. Oh, I haven't got the last half.
Performance.
Building performance. Thank you very much. There you go. 10 minutes.
I did realize that I'm the last presentation before the break. I promise you I'll make it short and interesting. Well, welcome to you all again. I'm Mohammad Mayouf. I'm a PhD researcher from TEE faculty, Birmingham School of Built Environment. I'm supervised by Professor David Boyd. He chaired one of the sessions in the early morning, and the acting head of school, City, and Professor Sharon Cox, who is not with us today. So today I'm going to present about towards better building performance through the use of building information modeling. Unlike the other researchers' approach, I'm not going to say what are my aims and objectives, methodology, and the way I'm forming my approach, because, to be honest, I hate philosophies. So in another way, I try to reformulate it in a different way. I'm going to address the issue, present the proposed solution, which is BIM, and then what is BIM doing for building performance. I think before going any further, it's really important to establish what is the understanding behind the word performance. So it's quite complex to understand what do we mean by performance. About a couple of presentations ago, Fahad has explained about business performance, but for building performance, what do we mean? Is it the building's life? Is it the building's interior? Is it the energy performance of the building, which most companies look at it for the moment? Is it maintaining the facilities within the building? Or is it about occupant satisfaction in the building? To be honest with you, it's all about this. That's why it's a concept. It's an interdisciplinary concept, and you can't really identify it. Unfortunately, if you see the left figure on the top here, it shows that there is a potential for the building. This is one example of a building, that the energy performance of it, and energy performance by mean the energy consumption of that building. It's potentially meant to be at grade C, which is very high, so it consumes less energy. However, once the building starts operating, it's at almost grade F. Very surprising. Why? And of course, us, the victims, you see people getting the temperature. It's too cold and too hot, and that's even within the same area. And on the other side here, so one side of the problem is buildings not perform as intended, unfortunately. Other side of the problem is performance is evaluated from a single perspective. Unfortunately, this is a very sad truth that always building management team take charge of the delivery of the building. So the client wants the building to be delivered with the minimum cost. The designer wants to deliver it with a higher efficiency. And the rest of the parties which play a main role in the delivery of the building, their main objective is just deliver the building with the minimum cost. So from this issue, my research has started. To be honest, the issue has been tried to be resolved by some of the approaches, like post-occupancy evaluation, which is on the right here. In simple terms, after the building is being occupied, number of questionnaires or survey using some parameters are distributed to the occupants, asking them about whether the temperature is comfortable, whether their working space is comfortable, whether they have the facilities. But does that solve anything? I can't move walls after the building is being built. I can't change a whole mechanical system for airing, for cooling, or for heating or cooling the building. No. And other approaches like building performance evaluation on the left. But these approaches, apart from them being limited, they are time-consuming, they are costly, and they lack of accuracy. There's an enormous amount of data that people won't even take on board. And especially on the left approach here, it has been used around the period between 1990s and beginning of 1995, beginning of 2000s. But people are not using it anymore because it costs money, because you collect enormous amount of data, and you don't basically achieve anything or reach anything. So if we summarize here, buildings is more than delivering the building itself. If you see the bigger circle, it describes what the real life is, what the actual truth is. There is There is always a desire to deliver the building, design and construction, and then operation, and then it goes with the less important to care about the planet, environment, sustainability, then less going into people, and then less the prosperity. From that point of view, I think my research focus would be on consideration of the multiple perspective. I think people who are involved within the building should be involved in the decision making. I'm not saying that occupants should go with the design team and tell them what to do. No, but if we take it here from the most important to the least important, building management team are the ones making decision, are the ones deliver the building. Facility management are the hidden angels of the building who are trying to maintain the balance between the building management team and the building occupants. And the building occupants are the victims, the ones that they don't have any contribution, and the ones who either be satisfied or totally unsatisfied within the building. So there should be a solution that can at least provide a platform which could collect all these inputs from the three different perspectives. It's building information modeling. Building information modeling, in simple terms, it's like a mutual platform where all the stakeholders within the building have their inputs: civil engineers, mechanical engineers, electrical engineers, architects, designers, client. They all share their information within single platform in a 3D model environment, and each one of them can get updated with any change. So with the use of this technology, we can see that there are very high detailed 3D buildings here. But again, I'm not trying to promote the technology, and at the same time, a lot of people understand that BIM models, it's a very fancy 3D models. In fact, it's not. BIM is a process. That's why it's called building information modeling. It's not called 3D modeling, because 3D graphics have been already since long time. But what building information provides is you can have input inside the 3D model. So what does BIM provide? It provides coordination, so it allows all the ones participating within the project to coordinate and collaborate at the same time. It detects the clashes between systems integrated within the buildings. It provides a full system integration. You can't imagine the number of systems within a building when you're all integrated in one single model, how enormous is that, and how big it is, and how difficult it was. Some companies like Autodesk Revit, at the moment they're providing a single interface for all these systems. Can you imagine? And it allows a pre-building navigation. The navigations within the building are normally developed after the buildings are being built. BIM actually provides you the chance to do that at the design stage. And it provides a life cycle information. So it goes not only from the design to the construction, it goes from the design, the construction, to operation, to whole life cycle of the building. And it provides an effective facility management tool, which I will explain later on what do I mean. So what does BIM support? What would BIM provide for building performance? For the building management team, it helps them to simulate energy within the building, as shown in the left figure. It delivers sustainability. This building, the one you are in now, has won recently an award. It was the most sustainable building in the West Midlands, and it was actually designed using BIM. All the systems within the building were simulated through BIM. And you can see that there's an accurate energy performance. It provides actual energy performance. So even though there is a little difference, the gap is not huge. For the facility management team, it helps them to manage the operation and management. So the active maintenance within the building, they can at least get information at the pre-design stage or at the design stage, where they know how systems are being repaired or replaced within the building. They can manage the space. They can as well. You can see at the right here, this is taken from one of the models where the information shown each component here, what its specification, manufacture, and how it's being replaced, the startup, the emergency shutdowns, and so forth. The building occupants, it gives them a pre-simulation for the indoor temperature, the space visualization, the place where they're going to work, and the facilities walkthrough to see which facilities they require. The future of building performance, we are really going after all that. We are going beyond the shell of the building and just the delivery of the building to the actual performance of the building from the inside, because that's where the problem lies. We're trying to bring the post-occupancy evaluation to pre-occupancy evaluation. We're trying to deliver an easier, smoother way for facility managers to manage the differences between the requirements between what the building management team wants and what the building occupants wants, and at the same time manage facilities within the building. Thanks very much. Have a good day.